Hello brothers. Welcome back to Soaring Brothers channel. We are in slow motion due to the pandemic lockdowns and government restrictions. Even, some delivery logistics have a couple of items on hold to be delivered, to let us finish our thermic dream. Once we have those elements in our hands, we'll continue our building, and of course, our thermic dream video series. Meanwhile, we've been thinking about the setup of the plane, and it comes to our minds a couple of projects we saw some months ago. First, we've decided to go for a deflection meter. A very useful tool to set up the plane as a starting point, using the designer's rules. This will be an electronic deflection meter, instead of manual protractor, and we want to show you the whole process. If you want to see it, please stay tuned, watch, give us a like, and remember, subscribe to our channel. Here's what we need to build it. We've called it the Soaring Brothers Deflection Meter. 1. An Arduino Nano board. 2. One LCD 1602, liquid crystal display. 16 characters by 2 lines, with I2C serial controller. 3. One MPU 6050, inertial measurement unit or a gyro with an accelerometer. This measurement unit is a very precise one. Even it detects the Earth Coriolis effect. 4. A solderless board. 5. A USB to micro USB cable. 6. Arduino IDE, Integrated Development Environment. This component is where we code the software for the Nano board. Let's get started with this, brothers. First, let's take a look at the circuit diagram to connect all the electronic components. Here, you can see the schematics. Please note that we're using only 4 pins to the LCD and 4 pins to the MPU. These are common pins: positive, negative, SDA and SCL. The SDA transmits the data, and the SCL is the clock to synchronize the transmission. The cabling colors here are blue for clock or SCL, and the SDA is on green. Please note that SDA and SCL from both the LCD and MPU goes to the same pins on the Arduino Nano side. We're using different voltages for those components. We feed the LCD with 5 volts, and the MPU are fed with a 3.3 volts. That is why we connect the VCC LCD pin to the 5 volts pin to the Arduino Nano board. The MPU VCC pin gets connected to the Nano board through the pin labeled 3V3. That's the orange cabling in the diagram. Both ground pins, marked as GND, of the LCD and the MPU gets connected to ground, GND pin of the Nano board. Those are the black wires. Please note that both SDA and SCL from both the LCD and MPU goes to the same pins on the Arduino Nano side. Okay, let's get real and build it. At least, as a prototype. Let us grab the boards, the cables, and the breadboard. there you go. Here's the finished physical circuit. Now we need to put some code into the Arduino Nano board. And here's the code. You can grab a copy of this code and use it for your board. This is our 2 cents to the community. Let's take a look. This portion of the code is to handle common functions for the data communications and the LCD display control. Here, we define a couple of variables to store data to be displayed through the LCD, and some configuration of the display as well. If you want to know more details about this coding, please throw us a line here in the comments. These highlighted lines initialize the display. You can change some of the printed text as you wish. And here is where the magic happens. Here we calculate the angle and filter the sensor lecture a little bit. After the calculation, we send the data to the console. This is only readable through a COM port. Then, we send the data to the display. Let's make some code comments here. It's always better to have a well-documented code, you know. And here we go to the compilation. Is everything okay? Let's check it out. Yeah, a successful compilation. Now we need to try it in the assembled circuit. Now we need to transfer this code to the Arduino Nano board. Once we've done it, let's plug the circuit to the outlet using the micro USB cable. And there you go. Take a look at the display. Now we can read the deflection angle of the control surfaces. We hope you enjoy this project. Go ahead and build one for yourself. In the description of this video, we're referencing the web address to download the code. Please, Remember to give us a like. Click on the subscription link and activate the bell to get our notifications for new videos. Thanks for watching. See you next time.